Hello guys, so we are back again. Hello. Okay, and today we are going to end our multiple correct questions. Okay, that is we have done till 20 questions, I guess. Okay, and we have completed from single correct. Okay, now let's move on till from 21 question. The 21 question is as follow. Okay, which says if okay, 21 question for 0. Okay, phi is between 0 to pi by 2. If x is equals to summation n is equals to 0 to infinity cos 2 n phi, y is equals to summation n is equals to 0 to infinity sin 2 n phi, and z is equals to summation n is equals to 0 to infinity cos 2 n phi sin 2 n phi, then x y z is equals to xz plus y, x y z is equals to xy plus z, x y z is equals to x plus y plus z, x y z is equals to y z plus x. Okay, now let's move on. Now, as I have told you throughout the whole chapter, that whenever summation appears, okay, try to open it. Okay, it will always give you a path. Okay, so my first job is to open it. When I open it, cos power 0 is 1. Okay, that you should have no doubt. At 0 it will then it will start with 2 5, and then cos 4 5, and cos 6 5, and so on till infinity, because it is going to infinity. Fine, anyone can do this. Now here you can see it is a summation, then 1 upon infinity sum. Here common ratio is cos square 5. Okay, easily see it, 1 minus cos square 5. So x is 1 minus cos square, but wait, sin square 5 is what? 1 minus sin square 5. That is the, okay, sorry, what is happening, cos square 5. Okay, this is class 10 formula, so we can use it. So x is equals to nothing but 1 minus sin square 5. Okay, so I got this, I will keep it as a. Okay, now my next step is open the second one. Second one is, I will think what I have to do, but first I have to get my xy value, because here you can see the equations we have to satisfy and check which are correct. Okay, so here is my sin 2n 5, then it will again be 1, then sin 2 5, and then sin 4 5, and sin 6 5, similar pattern. Okay, and so until infinity. Sum of the infinite terms 1 minus sin square 5. Here I can again use this formula and put here 1 upon cos square 5. So I will call it as b. So my second equation nothing but y is equals to 1 upon cos square 5. I got two equations. Now let's me take the next page. In the next z1, which is summation n is equals to 0 to infinity cos 2n 5 into sin 2n 5. Okay, if I open it, 1 plus cos square 5 into sin square 5. Don't get scared of this. Okay, just be calm. Okay, you will get your answer. Okay, mostly children get scared. Okay, what formula I will use here. Okay, so and so until infinity. Now here r is what? Cos square 5 into sin square 5. Okay, so my z will be what? 1 upon 1 minus cos square 5 into sin square 5. Okay, so after this what we can do, we can substitute from here sin square 5 value. Okay, so from a you can easily get sin square 5 is equals to what? 1 by x, and from b cos square 5 is nothing but 1 upon y. Okay, simple. So after this, let's substitute the value 1 upon 1 by x into 1 by y. Okay, which gives me 1 upon xy minus 1 upon xy, which will give me xy upon xy minus 1. Okay, so here is my z. I will multiply xyz minus z should be equal to xy, giving me finally xyz is equals to xy plus z. Okay, so I can see there can be chances of it. Okay, second is the answer. Now can the other can be option? Okay, so now let's verify. Okay, we can this one. Okay, this one, if it was about to be correct, this and this are same, Okay, and these are same. Okay, so the probability of being all of three means any one can be correct. Okay, they all cannot be correct. Here I can easily make out from that, because why, all of them have same pattern. X y z is equals to, I have proved there can be only one true. Okay, and which I came. Okay, and there I don't have any idea that how I can prove this, because it came directly. Okay, now the last which is different is this one, which we have to prove. It is different from all of three because it is x plus y plus z. X plus y plus z is what, 1 upon x is what, 1 upon sine square 5, 1 upon cos square 5, and this is what, 1 upon sine square 5. Okay, 1 minus sine square cos square 5. Okay, now here if I multiply, I will get at the top 1, because sine square plus cos square 5 is 1, and here it will be sine square 5 into cos square 5. Simple. Okay, and 1 upon same thing, sine square 5 into cos square 5. Okay, so here if I multiply in the top, basically they will cancel out, but I will show you how it cancel out, otherwise you will have doubt. Okay, cos square 5 plus sine square 5 into cos square 5. Okay, and after this what I will do, multiply them, sine square 5 into cos square 5 into 1 minus sine square 5 into cos square 5. Okay, this is very step. This and this will cancel out, giving me finally 1 upon sine square 5 into cos square 5. Okay, 1 minus sine square 5 into cos square 5. Okay, so but if you remember properly, 1 upon sine square 5 is nothing but x, sorry, it is y, and this is x and this is z. So we have proved that x plus y plus z is nothing but x y z. Okay, so the hope you have understand the process, ideology behind how we approach. Okay, whenever you get submission, don't have to think much, you have to just open them and then identify what you have to do in the next step when submission appears, because after submission, opening the submission, you can get an idea. Okay, that is the problem in submission type problems, because if you don't open submission, you don't know what it will give finally. Like a submission open, we got the idea that xyz, how we have to approach the problem by proving. Okay, now let's move on to the next question. Okay, let me take this page also. Okay, the next problem is this. Okay, which says 22 for the series s is equals to 1 plus 1 upon 1 plus 3 into 1 plus 2 the whole square plus 1 upon 1 plus 3 plus 5 into 1 plus 2 plus 3 the whole square plus 1 upon 1 plus 3 plus 5 plus 7 into 1 plus 2 plus 3 plus 4 the whole square, and so on. Okay, the first option is 7th term is 16, 7th term is 18, sum of first 10 term is 505 by 4, sum of first 10 term is 405 by 4. Okay, now here can you identify the tn term? Okay, tn term identifying is very difficult. Okay, if you can identify the tn means what will be the last term. Here it is very obvious that the tn term will be what? Okay, the tn term in the n term, there will be sum of all odd numbers. Okay, so the tn term here, the n term will have what? N means all odd numbers. Okay, so odd numbers. Okay, all odd numbers like 1 plus 3 plus 5 and so on. Okay, till what is the last odd number? 2n minus 1. Okay, and if I think here will be sum of all numbers square, and so on till n square. So we know one thing. First we want to find the sum of odd number 1 by 3 plus 5. Okay, till 2n minus 1. Okay, if you know it is directly n square, then fine, I will prove it also. Okay, how we prove it? Okay, so here its sum of all odd natural number is n square. Okay, how? Let me prove this. Okay, I'm proving that. Okay, odd numbers. Okay, don't think that I'm proving something else. Okay, I'm proving this, how it n square came. The last term is nothing but 2n minus 1. Okay, if I do the summation, I should get n square. Okay, if I do summation, here will be n into n plus 1 by 2, sum of all summation of, and here will be n. Fine, then 2 will cancel, giving me n square plus n minus n. Now you can see it is n square. Okay, sum of odd numbers, odd, n square. I proved that, and now you know the sum of these numbers. So here's n into n plus 1 the whole square upon 4. Okay, n into n plus 1 by 2, its square will become what? N square, n plus 1 the whole square, and 2 square, which is 4, and here it will be n square. So this and this will cancel out, giving me finally n square plus 2n plus 1 upon 4. Okay, so I got my Tn. Okay, now method 2, this is method 1 to approach to this. Okay, after this the process will be same, but method 2 is also quite means a good method. Okay, if you observe, it is nothing but just using this only. Okay, but in a different way. Like here, you know that if I add this, it is 4. If I add this, it is what? 1 plus 2, 1 plus 3 plus 5, it is what? 9. And this is what? 1 plus 3 plus 5 plus 7. Okay, this is 8, 8 plus 9, 9 plus 1, 7, 16. Okay, so here you know that after this what will happen. If you observe, it is 4, it is 9, it is 16. So can I directly write it? It is n into n plus 1 by 2 the whole square upon n square. What you observe the pattern, here it is 4, here it is forming 9, here it is forming 16. So the nth will be n square only. So you will again get n square plus 2n plus 1. So okay, don't get surprised. Okay, the method just changes, but the means the final thing is the same only. If you know this thing, okay, then also not a problem. Okay, after method 2 the job is like this. Okay, you want to find the 7th term. T7 will be what? Just put the value. Okay, this is our Tn only. This T7 we want to find. Okay, T7, Tn we have n square plus 2n plus 1 by 4. Okay, T7, how we will find the T7? Okay, T7 is means just put the value T7. This is 49 plus 14 plus 1 upon 4. Okay, so here it will become 49 plus 15 upon 4, giving me finally, okay, which will give me finally, okay, let me check, calculate. Okay, I don't have, okay, I have to calculate. I have to calculate n square. I have to put the values. Let me check. Okay, if I add here, okay, it will be 14 and this is 6. Okay, 4, which will give me 16. Okay, so my 7th term is 16. So the first option is correct. Okay, so the first option is correct. Now the second option, 7th term, is wrong. Okay, automatically. Sum of 10 terms. Sum of 10 terms means what? Tn you will apply summation. Okay, to get sum of 10 terms from what? N is equals to 1 to 10. Okay, that is the means process. N is equals to 1 to 10, n square plus 2n plus 1 by 4, which will give you what? Here you will always will do this, move the constant outside. Here it will be n into n plus 1. Okay, upon n square is what? N into n plus 1 into 2n plus 1 by 6. And this is what? 2 into n plus 1 by 2. Okay, and this is n. Okay, finally you are getting this. Okay, after this what you have to do? After this what you have to do? You have to substitute the value, which will give you like this. Okay, first here it will be 10, here it will be 11, this will be 21 by 6, giving you here 10 into this will be what? 11. Okay, 2 will cancel out this, and this will be 10. Okay, which will give you what? Which will give you 505 by 4. Okay, because here 3 2. Okay, and then 3 will divide by this 7 and then into, okay, let me this only, otherwise you, okay, 5, this will be what? 3 this will be 11 into 7, and this will be what? 1 10, and this will be 10, which will give me 120 finally. Okay, and which if I add on, this will cancel out, and but it will still remain, so we'll don't multiply. Finally our answer will be 505 if you multiply 55 into 7. Okay, and so on. Okay, now so our third option is correct. Okay, now let's move on to the next option. Okay, hope you have understand the process, how we proceeded. Okay, how we consider the Tn term. Okay, the process is same. In summation we find the Tn term. Okay, like we want to get our Tn term. Okay, what will be the Tn term? This, okay, they are adding the sum, but here it is a series. This will first term, second term, third term, fourth term, and all the term will add on to give me summation. So I identify my Tn term. Okay, there are two methods to identify. I told you both the methods. Okay, it's up to you which method you use. Okay, so now let's move on to the next. Okay, the next question is this. Okay, let me get the page. Okay, where is 23rd? Okay, I got the 23rd question. Okay, this is the question number 23. Okay, it says if summation r is equals to 1 to n r into r plus 1 into 2r plus 3 is equals to a n power 4 plus b n cube plus c n square plus d n plus e, then first a minus b is equals to d minus c, second e is equals to 0, third a comma b minus 2 by 3 comma c minus 1, sorry, comma c minus 1, right? R in ap, b plus d by a is an integer. Okay, now how we can prove this? Okay, that is means a good, this is a good question. Okay, now first in summation we will what multiply them. Okay, because the maximum digit here can be formed is what, cube. Okay, so we will do what, we will just multiply them. Okay, first I will simplify the thing which I have inside. Okay, I will not put summation and all that stuff. First my job is to simplify. R square plus r into 2r plus 3, which will give me finally 2r cube plus 3r square plus 2r square plus 3r, finally ending up as 2r cube plus 5r square plus 3r. Okay, now I will do what, I will apply summation. Okay, I will apply summation from r is equals to 1 to n. Now I have the multiplied one, 5r square and 3r. Okay, I will apply the summation. After applying summation, what I have, r square into r plus 1 the whole square upon 4. Okay, you should know all the summations of cube squares. Okay, r into r plus 1 into 2r plus 1 by 6. Okay, and plus this one 3r into r plus 1 by 2, which will give me what, r square into r square plus 2r plus 1 upon 2 plus 5 by 6. Okay, this will end up giving me r square plus r into 2r plus 1 plus 3. Okay, this will give me 3 into r square plus r by 2. Okay, and after this step what we will do, okay, we will multiply this r square with this, which will give me, okay, and also one more thing, here I can make the base same. Here I can make the lowest common multiple is 6. I will make the denominator 6, so I will take 6 common. Okay, for that I have to multiply here 3, then it will become 6, and I have to multiply here 3, then it will become 6. So I will take 6 outside, which will make it 3. Okay, 3, here it will become 3. Okay, I will just multiply r square. Okay, okay, my next job is to just multiply. Okay, and then the rest thing will be same. Okay, 3r power 4 plus 6r cube plus 3r square plus, okay, 10r cube plus 15r square, okay, plus 5r plus 9r square plus 9r. Okay, which will, okay, now if I add them, what I'm getting, some finally 3r power 4 plus 16r cube, okay, sorry, 16r cube and what, 27r square and 14r. Okay, this is what I'm left with. Okay, now now it they are setting it is equal to n power 4 plus b n cube plus c n square plus d n plus e and so on. Okay, now here we have to solve by comparing. This is very, okay, any small child can even understand that when it is placed equal we have to solve by comparing. So a will be what, 3 by 6, b will be what, 16 by 6, c will be what, 27 by 6, and d will be what, 14 by 6. Okay, now let's move on to the next page. Okay, sorry, this page is already used. Okay, so the next page, a will be our modified 1 by 2, b will become what, b will become 8 by 3. Okay, c will become 9 by 2, and d will become 7 by 3. Okay, now after this we have to prove a certain, I got the values, I have to prove that a minus b is equal to d minus c. How we can prove? 1 by 2 minus 8 by 3 is equals to, I am substituting the value to prove this. Okay, first option. That is the problem in multiple choice question, you have to check for each and every option. 14 minus 27 by 6, which will give you finally minus 13 is equals to minus 13. So my first option is verified. Second option, in the second option it is very easy, e. Okay, here there is no e. Okay, here there is no e only, so e will be 0. Okay, here there is e, here there is no e term, no single constant term, so e will be 0. So my second option is also verified. Now the third option is what, checking for a comma b minus 2 by 3 comma c minus 1. Okay, which is 1 by 2 minus 8 by, okay, 8 by 3. Okay, 8 by 3 minus 1 comma 9 by 2 minus 1, which will give me 1 by 2 comma 8 minus 2 by 3. Okay, 8 minus 2 by 3 comma 9 minus 2 by 2. Okay, so here they will cancel out and give me finally 1 by 2 comma 2 comma 7 by 2. Okay, now if I check them, for them to be in AP, 2 into 2 should be equals to 1 upon, this will become constant and same, this will become 8 by 2, which will give me 4, and if you multiply this it is also 4. So the third option is also correct. Now let's check for the fourth option, which says b plus d by a is an integer. B is what, 8 by 3, d is what, 7 by 3, a is what, 1 by 2, here 1 by 2, 2 will move here, then it will become what, 3 by 8, some 15, and here this will cancel out, giving me 2 into 5, which will give me 10. So it is an integer. So all the 4 options are correct. Okay, so this question was tricky. Okay, all the 4 options are correct. When I see any question of whose 4 options are correct, it means a quite means time inducing type question. Okay, now let's move on. Okay, hope you have understand each and every step, how I proceeded, how I multiplied, okay, simplified my job, then applied summations, opened the summations, identified the each terms. Okay, now I want to tell you that that there is one more method by which you can solve this. Okay, the other method by which you can solve this is nothing but, okay, I will just do the same step. Okay, the method 2, okay, the method 2 is nothing but you have to just play smartly. R is equals to, if you play smartly, you don't have to do the multiplication. Here r plus 1 you have, okay, 2r, this I can make 4 and subtract 1. Okay, what was the purpose of doing that? Okay, then I can break it up, like how, like I will take this, you observe here, I will multiply this with this and 2r plus 4 with this, and then multiply r into r plus 1. Okay, now here summation will move on, break up. Okay, r is your summation will be still same. Okay, don't get confused, summation value will differ. No, it will not differ. 2 will move out. Send my final r is equals to 1 to n r into r plus 1 into 2 into r plus 2. Okay, and here r into r plus 1. Okay, summation here will be there. Okay, minus. Okay, summation will still be there. Okay, so I got my summation. Okay, now what we have to do? Okay, r is equals to 1 to n. Okay, so we are done with this. Now after, when you open this again, when you open this summation, you will still get the same answer. Okay, so when you open this, you will still get the same. Okay, you will end up getting here only 1 by 6 summation 3r power 4 16r cube and 27r square. Okay, plus 14r. Okay, after this the process will still be same, but this will reduce your job because you have separated out. You don't have to compare all. The probability of getting wrong answer is in this. Okay, so that was the purpose of doing this method. Okay, so make you understand that by this method also the question can get solved, while this method is quite easy. It will break you and make you easily, because terms will cancel out. Okay, only main terms will remain. Okay, so now let's move on. Now let's move on to the next question. The next question is this one. Okay, let me get the page. Okay, now this question. Okay, this is 24th question. If Sn is equals to 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square and so on, then first S4t is equals to minus 820, second S2n is greater than S2n plus 2, and third is S51 is equals to 1326 and S2n plus 1 is greater than S2n minus 1. Okay, now how we can solve this? Okay, first you should understand the basic thing. Okay, that if you will don't means we have done this type of question. Okay, this question, okay, I have derived the means I have done a question in while explaining the chapter only, this type of questions. Okay, in this type of question always check. Okay, here two cases can occur, two cases. Okay, two cases can occur. Okay, occur. Okay, two cases. First, if n is even. Second is if n is odd. If you observe very clearly, all the even terms have negative sign. If my last term is even, then it will have negative sign, while if my last term is odd, then it will have positive sign. Okay, now let's take the case 1. Case 1, that is n is equals to even. So what my Sn will become? Just see this: 1 square, 2 square, 3 square, 4 square, 5 square, minus 6 square, and so on. The last term will be what? N square, and before it will be n minus 1 the whole square. If it is even, this will be odd and it will have negative sign. This will have negative sign, and if this is odd, it will have positive sign. Okay, fine. Now it is very obvious that I will apply a square minus b square here everywhere. So 1 minus 2 into 1 plus 2. Similarly here 3 minus 4 into 3 plus 4. Similarly in the next 5 minus 6 into 5 plus 6, and so on will move on. N minus 1 minus n into n minus 1 plus n. Okay, now all the terms have minus 1. This will become minus 1, this will become minus 1. Okay, let me write also minus 1 into 1 plus 2, minus 1 into 3 plus 4, minus 1 into 5 plus 6, and the last term will have minus 1 into n minus 1 plus n. Okay, so here if I take minus 1 outside, then what I'm left with? 1 plus 2 plus 3 plus 4 plus, okay, and so on till n minus 1 plus n, all the natural, and this is what? Sum of natural numbers, okay, which I know already it is nothing but n into n plus 1 by 2. So my answer is what? Minus n into n plus 1 by 2 when n is even. Okay, first thing, okay, I will keep it as A. Second, case 2, okay, I will do it here only. Okay, save my page also. Case 2 is what? N is odd. Okay, n is odd, Sn will be what? 1 square minus 2 square. Starting will be same, don't get confused in the starting, the last term will decide. Okay, see how it differs. Okay, the last is odd, it will be positive, but before that it will be even, so it will be minus 1 the whole square. Do you agree with this? Okay, it is very obvious, the before that will be even. Now after this again I will apply 1 minus 2, 1 plus 2. Okay, I will not do this step, okay, this minus 1 writing step, you should understand. Okay, because 3 minus 4 and 3 plus 4, 5 minus 6 and 5 plus 6, okay, and so on. Here I will have what? But listen, this, if you know in odd terms, if I tell you there are 7 terms, 1 2 3 4 5 6 7 terms, okay, I will tell you make a 2 2 pair, the last term will be left. Okay, if it is odd then it will be left alone, it cannot form pair with. Okay, the last term will be end alone. If you know in odd terms there are only one middle term, while in even terms there are two middle terms. Okay, using that also concept you can analyze that why it will be left alone. It will be left alone because all these forms will form n terms. Okay, they will form pair, but it will be left alone. Before this it will be n minus 2 the whole square, so it will form n minus 2 minus n plus 1 and n minus 2 plus n minus 1. Okay, I'm writing here, and it will be left with n square. Okay, so this is, after this it will be what? Minus 1 into 1 plus 2 plus minus 1 into 3 plus 4 into plus minus 1 into 5 plus 6, and it will move on till minus 1 into n minus 2 plus n minus 1, okay, plus n square. Okay, whole close. Okay, so I have to edit this. Okay, now here I will take the minus 1 outside, which will give me 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on till n minus 1. I will be left, n square will be left alone. So I know the sum of this. Okay, you know what we will do? We will write this n into n plus 1 by 2 only. Okay, we will write, this is minus sign. Okay, and here will be n square left. Okay, so what we are going to do? Okay, we have taken minus 1 from this. Okay, so in this step we will replace n by n minus 1, because my last term is n minus 1, it is not n. So this formula will be valid when if n is replaced by n minus 1. That is the trick. And while teaching the chapter I have told you many times that when that term ends, till if there was n minus 2 terms, okay, then I would replace n by n minus 2. Since here it is ending up with n minus 1, I will replace n by n minus 1, so it will give me n minus 1. Here if I replace n minus 1, it will become n only, so n upon n minus 1 by 2. Here it will be negative sign plus n square. If I further simplify, okay, let me take the next page. If I further simplify, I am getting what? N square minus n by 2, outside will be negative sign plus n square, which will give me minus n square plus n. Here it will become 2n square upon 2, which will give me, 1 will cancel out, give me n square plus n upon 2, and my final answer is nothing but n into n plus 1 by 2 only, but with positive sign. Okay, so I got two answer, I will call it as B. Okay, when n is even and when n is odd. Okay, now if you see the option S40 means n is even. Okay, 2 into n. Okay, S even, so S40 I will find out with what? N into n plus 1 by 2. Even will have negative sign. Okay, so I will apply, put 40 into 41 by 2, which will give me my final answer. This will cancel out, give me 20 into 21, okay, which will be nothing but, okay, I will get my final answer. Let me calculate, minus 820. Okay, so yes, this is correct. Okay, now we want to check for this one, S51 is odd. It will be checked by n into n plus 1 by 2, positive 1. 51 into 52 by 2, which will give me nothing but, okay, it will be, okay, I'm checking 51, fine. Okay, what will be 52? So 51 into 26 will give me 1826. Okay, so what I'm left with, Okay, I have calculated right. 1326, sorry, 1326. Okay, so what value I'm getting? 1326. Okay, and but here it is, okay, right. So third is also correct. Now I have to check for the second two. If you know S2n, okay, S2n will be what? 2n into 2n plus 1 by 2. Okay, this will cancel out, giving me n into 2n plus 1 by 2. Fine. S2n is even, so it will have negative sign while checking. So it is negative. Okay, while this one is also even. So S2n plus 2, if I check, it is nothing but minus into 2n plus 2 into 2n plus 2 plus 1 upon, I'm just substituting the value, nothing. Okay, this will become n plus 1 into 2n plus 3 upon 2. Okay, but if you observe, this one is bigger. Okay, listen, wait a minute, this one is bigger because n plus 1, 2n plus 3 upon 2. Okay, this will have higher value and this will have lower value, but due to negative sign this will become greater. So S2n will be greater than S2n plus 2. Hope you have understand. This is greater in magnitude, it is greater, but due to negative sign, it will become greater. Okay, so that is the reason that S2n is greater than S2n plus 2. Okay, so for second one is also right. Now let's check for S2n plus 1. We will check it, since it is odd, we will check with the negative one, a positive one. 2n plus 1, this will become 2n plus 1 by 2, giving me finally 2n plus 1. This will become 2n plus 2 by 2, which will give me 2n plus 1 into n plus 1. Okay, finally. Okay, so here now if I check S2n minus 1, this will be 2n minus 1. Here if I place 2n minus 1 plus 1 by 2, they will cancel out, giving me 2n minus 1. This will become n only. 2 will cancel out. So which one is bigger? This one is bigger, but here there is no negative side, so magnitude will only decide what is the greater. So S2n plus 1 is greater than S2n minus 1. So fourth one is also correct. See, this question is also means quite time inducing question. Why? Because we have to check all the 4 options. Now let's move on to the next question. Okay, let me take this page also. Okay, the next question, okay, is 25th question. Okay, this is the 25th question. Okay, let me get the page. Okay, fine. Now whenever you see a pattern, okay, under root, okay, you have to solve it with more correct approach. Okay, so 25th question says 1 upon under root, okay, 1 upon under root 2 plus under root 5 plus 1 upon under root 5 plus under root 8 plus 1 upon under root 8 plus under root 11 and so on till to n terms is equals to what? Under root 3n plus 2 minus under root 2 by 3. Second, n upon under root 2 plus 3n plus under root 2. Third option, less than n, less than under root n by 3. Okay, now whenever you see these type of patterns under root and the best approach is rationalize. In limits also you will do rationalize continuously when you will come across algebraic limits. Okay, so this pattern is very obvious. Okay, you have to rationalize. Okay, this is very general approach, so I will rationalize. Okay, but what mistakes children do? See, if I have this under root 5, children will rationalize with under root 2 minus under root 5, which will make them trouble like this. It will happen like this: under root 2 minus under root 5 upon minus 3. See, negative sign appear. Why appear negative sign? That's why, to avoid that, you should do this thing: 1 upon under root 2 plus under root 5, you should try to multiply minus 2 by, because positive you can rotate, doesn't matter. Okay, then it will become 5 minus 3, giving you 5 minus 2, which will give you easily under root 5 minus under root 2 by 3. Okay, so this is the approach to rationalize. Okay, that is, now I will rationalize. So in the top I will have 5 into under root 2 upon 3, but here if I rationalize bigger one, okay, I will just take the bigger one only because I have to remove the negative sign, otherwise all the series will become negative. Okay, not a problem, but it will increase your work only, because it will negative, you have to take the negative and then apply the things. Okay, but your answer will become right. Okay, don't worry. Okay, so after this, under root 11 minus under root 8 upon 3. Okay, 11 minus 8 is 3. Now what will be my n term? Okay, n term, okay, let me get the decide the n term. Here it is 5, then it is 8, so apply it, we can n minus 1 into 3. I can write it like this: 3 will be there only, minus here it is 2, then it will be giving 5, 2 plus n minus 1 into 3. Okay, 3 by 3 only it is increasing. Okay, so 3. Okay, let me write again. Okay, under root 5 plus n minus 1 into 3 minus under root 2 plus n minus 1 into 3 by 3. Okay, so this is my Tn term. Okay, so if you open the series, you will see a thing happening. 1 upon 3 under root 5 upon 3 minus under root 2 upon 3 under root 8 upon 3 minus under root 5 upon 3. Okay, under root 11 upon 3 minus under root 8 upon 3, and so on. Okay, what will be the last term? Under root 5 plus n minus 1 by 3. Okay, minus under root 2 plus n minus 1 3 by 3. Okay, now you can see this term is cancelling out with this is so all the terms are cancelling out except this. But here, to check out of this which one will cancel out, we have to take one term before it. Okay, so we are going to take one term before it by substituting here n minus 1. 5 plus this will become n minus 2 into 3 upon 3, and this will become under root 2 plus n minus 2 into 3 upon 3. So after simplifying, what I'm getting, 3n minus 1. Okay, 6. Okay, minus 1 upon 3 under root, and here I'm getting 2 plus okay, this will be 6n. Okay, this will be 3n. This will be 6 minus 4 upon 3. Okay, so you can see. Okay, we will here substitute. Okay, we will simplify this also. So let me simplify it again. So here I know, and minus 2 by 3 is left here. Okay, that I know. Minus 2 by under root minus 2 by 3 is left. But in the end, I want to know what is left. So I am simplifying 3n minus 1. Just n minus 1 term I simplified. 3n minus 4 by 3. I will simplify this one, which will give me 3n under root 3n plus 2 upon 3. All the terms will cancel out except I know that much. Okay, this will become 3n minus 1 upon by 3. So you can see clearly this and this term is cancelling out, and okay, and this is just before it, so it will also cancel out with term means term appearing just before this under root 3n minus 1. Okay, so the last term is this is left. Okay, so now we have got what terms are left. Okay, many children have doubt that how to identify what term is left. Okay, so this is the approach. Take the n minus 1 term also. So 3n plus 2 minus under root 2 by 3. Okay, now I will okay, is there in okay, my first option is correct. Now I will rationalize. By rationalizing, what I am getting, 3n plus 2 minus 2 upon 3 into under root 3n plus 2 plus 2, which will give me, this will cancel out, giving me 3n upon 3 into 3n plus 2 plus under root 2, which will give me 3 will cancel out, so on. We are left with 3n plus 2 plus root 2. Okay, so this is the thing which we are left with. Now this thing, okay, is it less than n? Okay, less than n is equal to less than n. This one is okay, this one is also correct, n upon under root 3n plus 2. Okay, now second one, now third one is less than n. So you can easily understand it is divided by some constant, so it is less than 1, less than n. Okay, less than n, fine. Is it less than under root n by 3? Less than under root n by 3. Now just observe one thing, that under root n means it is more small, because you are taking 4 under root will 2, it is just reducing to half only, so it means n is reduced to half, so this will not be greater than, okay, it will be less than all of them. Under root n by 3 will be less than all by 3, because under root taken means it is reducing n value by half, and root 3 means 3 value is also reduced. Okay, so n by root 3 n plus 2 plus under root 2 will surely be greater than this. Okay, now let's move on. Okay, so this one is correct and this one is wrong. Okay, so we are done with all the options. Okay, now let's move on to the next problem. Okay, the next problem is like this, the 26th problem, which says in the 20th row of the triangle. Okay, a triangle is forming 1 2 3 4 5 6. Okay, 4 5 6, and like this 7 8 9 10. Okay, the first row, second row, third row, fourth row, like this. Now the last term is, okay, we want to find the last term of 20th row. Okay, understand the question. In the 20th row of the triangle, okay, last term is this, first term is 1 9 1, sum of the 20 term is this, and they are telling, okay, out of this any one can be true. Okay, it is very obvious. Now to approach this problem, okay, we will, now instead of means carrying you, they should have given it like this. Okay, 1, first term is 1, second term can be 2 3, 2 term, third term will be 4 5 6. Okay, 3 term it has, third term means third row, second row, first row. First row has one term, second row has two term, third row has three term, fourth row has four terms, 7, 8, 9, 10. And now the fifth term will be what? 11, 12, 13, 14, 15, and so on. So can I say the nth term will have n terms? Okay, but I know the sum of n terms. Okay, sum of n terms I know. So sum of n terms will give me my Tn term, which will be what? N into n plus 1 by 2, because in the nth term there will be n term. I know the sum of n term, so using that I can identify the any row's last term. Okay, like okay, so we got an idea that how many terms will be there in the last term. Here it is 5, here it is 4 in the third row, fourth row is third row is 3, second row is 2, first row is 1. Okay, and in the fourth row is 4, in the fifth row is 5. Okay, now in the nth row there will be n terms. Basic logic. Now we know the sum of n if there are n terms. Okay, no matter what pattern they are, but sum of n terms is n into n plus 1. This you should agree. Now we will check that whether this Tn term will give me answer. Now let's check whether the last term means second row, if I put t is equals to n is equals to 2, can it gives me 3? 2 into 2 plus 1 by 2, it is giving me 3. So I came to know the last term of this. Can I know the last term of fourth row? 4 into 4 plus 1 by 2, which is giving me 2 into 5. Yes, 10. Can I know the fifth term? Yes, 5 into 5 plus 1 by 2, which is giving me 5 into 3, 15. Okay, so similarly, can I know the 20th row term? Yes, T20 will give me what? 20 into 21 by 2, which will give me what? 10 into 21, which is nothing but 210. Okay, so my last term is very easy, 210. Now let's move on. Okay, now I will do it here. Okay, suppose this is my nth row, okay, or 20th row. Some terms A, B, C, some terms are appearing, and here I have 210. Fine. Now the first is 1, 2, 3. Okay, all have D 1, so it will also have D is equals to 1. Okay, they are following a pattern now. 1, 2, 3, 4, 5, 6. Okay, all have D1, 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 D1. So the nth row will also have D is equals to 1. Although the last term is 2, 1, 0. Okay, so I got D is equals to 1. So can I apply Tn? Okay, this I can take a separate series. Okay, I am taking it as a separate series and applying a Tn. Okay, otherwise you will claim that A should be 1. Okay, so A plus bracket n minus 1 into D. Now you should never say that A is equals to 1. Why? Because I am taking the last series as my series, last term as my series. Okay, so A will be, I don't know. Tn I know. Yes, I know this series last term is, that means 20th row I am finding. A I should know. 20th row is what? 20 minus 1 into D is what? 1, which will give me A is equals to what? 2, 110 minus 19, which will give me A is equals to 191. So my first term is also correct. Now sum of 20 terms. Sum of 20 terms. Okay, how we will find the sum of 20 terms? N by 2 bracket 2A plus bracket n minus 1 into D. We will apply this sum of 20 terms because it is a AP. Okay, 20 upon 2 bracket 2 into 191 plus bracket 19 minus 1. Okay, sorry, 20 minus 1, which will give me 19 into D, which is 1 only. Okay, so here it will become 10 into, okay, 2, 8, 3 plus 19, which will give me finally 10 into, okay, which will give me finally 401 into 10, which I will give me final answer 10101. Okay, what is, okay, so third is also correct. So hope you have understand what we did. We identified first has one term, second row has two term, third row has three term, fourth row has four term, five row has, so the 20 row will have 20 term, and then we generated a general pattern that n term will have n term. We know the sum of n term no matter what, where it start, like here it is starting from 11, doesn't matter, there will be n terms. Okay, and I know the sum of n terms. I got that. Then I verified this whether can I get the last term using this. I put third term, I got the last term. I put the second, I got the second term last term, second row last term. Similarly, I put the 20, I got this 20th row last term. Then I consider the last row as my series A, B, C. I don't know from where it start. Okay, I take the first term of this series as A, and the last term I know. Then I apply Tn is equals to A plus n minus 20. 20th row, so apply put 20, n is equals to 20. Don't put here 1 because you are not taking, it is a part of the series, okay, of the triangle. Okay, then 20 minus 1, it is 19. Then a I'm getting 191. Then I want to know the sum. Okay, although I can have applied summation tn also, doesn't matter, but since it is ab, we should take the advantage of the things which already have. I have already have dA, so why don't go for that thing? Okay, so n by 2, 2a plus bracket n minus 1 into d. Okay, so hope you have understand. Okay, this one was for sure, anyone will be wrong. Okay, this one will be wrong. Now let's move on to the next problem. The next problem, let me get the page. Okay, so this is the next problem, which is telling given that x plus y plus z is equals to 15 when a comma x comma y comma z comma b are in AP, and 1 upon x plus 1 upon y plus 1 upon z is equals to 5 by 3 when a comma x comma y comma z comma b are in HP, then GM of a and b is 3. One possible value of a plus 2b is 11. Third option, AM of a and b is 6. Greatest value of a minus b is 8. Okay, so we want to check for this. Okay, now just listen this out. A, X, Y, Z, B are in what? Are in what? AP. So do you know the arithmetic mean concept that a plus b by 2 should be equal to z plus x by 2? How you write that? Remember, the sum of all the terms should be n plus 1. Subscript. Okay, I have discussed in detail when I was teaching the chapter sum of subscript concept. Here, this is first term, this is last term. They are adding. Okay, there are how many terms? 1, 2, 3, 4, 5. Okay, when I add, no matter which two term I take, their position should give me always one term greater than how many terms are there in the series. 1, 2, 3, 4, 5. So I should get 6. This is first, this is fifth. So 5 plus 1, 6. Okay, this is first position, this is fifth position. 5 plus 1, 6. So this is right. Where I can write a plus b by 2. Okay, then similarly I can write x plus z by 2. Why? Because it is second. This is what? 1, 2, 3, 4. 2 plus 4 is 6, again greater than 5. So I can write this, and it will be equal to the middle term y. So after this I can write a plus b is equals to z plus x. I multiply through, I get 2y. Fine. Now I can use this relation, keep it as a. I know x plus y plus z is equals to 15. I will put x plus z value as a plus b. I will put z value, okay, y value as a plus b by 2. Very easy. Y value will be what? A plus b by 2. Why I am putting a plus b only? Because my options are in a and b. I have nothing in x plus y. Otherwise there was no reason for substituting a plus b. Okay, so you should understand what the purpose behind this, why I am substituting a plus b. Okay, so it will give me 3a plus b by 2 is equals to 15, giving me finally a plus b is equals to 5. 5 2 is 10. Okay, so I got a plus b is equals to 10. Okay, I will keep it as b. Now in the next, okay, what I have 1 upon a, 1 upon, they are in HP, so I can write in AP 1 upon z, 1 upon b. Similarly I can write 1 upon a plus 1 upon b, okay, by 2 is equals to 1 upon x plus 1 upon z by 2 is equals to 1 by y. I will multiply throughout by 2, giving me finally, okay, so 1 by a plus 1 by b is equals to 1 by, okay, 1 by x plus 1 by z, which will give me 2 by y. Okay, so finally what we are left with, okay, this is the general thing which we have. So we will substitute here 1 by x plus 1 by y plus 1 by z, okay, is equals to 5 by 3 they have given. I will substitute x plus 1 by x plus 1 by z as 1 by a plus 1 by b. I will substitute 1 by y as what? 1 upon 2a plus 1 upon 2b as my y, and then here I have 5 plus 3. Okay, then in the next step what I can do, okay, in the next step what we will do, we will just simplify them. Okay, simplifying is not a big task. Okay, now let me get the next page. Okay, I'm not doing any mistake, all right. A plus b plus x plus z. Okay, fine. Now let's do the problem. Okay, so a plus b by ab. Here I will take the 2 common. I will write here a plus b by ab. Okay, and here it is 5 by 3. Again I can add them since bases are same. 3a plus b by 2ab will be my 5 by 3. I know a plus b is 10, so 3 into 10 upon 2 into ab should give me 5 by 3. This will cancel out 2's, this will become 6. Okay, and okay, this will cancel out, giving me 5. 5 will cancel out, so a into b will be what? 9. Okay, so I got a into b is equals to 9. so I will call it as C. Now I want to get A and B value before I proceed. Okay, so how I will get my A and B value? Okay, so I can write A as 10 minus B from B, then I will substitute it in A. 10 minus B into B should be equal to 9, giving me 10B minus B square is equals to 9, giving me B square minus 10B plus 9 should be equal to 0, giving me B square minus 9B plus B plus 9 should be equal to 0, giving me B is equals to B minus 9, giving me minus 1 into B minus 9 should be equal to 0. So B is equals to 9 comma B is equals to 1. Okay, so I got two B values. Okay, so I got two B values. Now how I can proceed? So when, okay, now let me take, okay, I will do it here only. When B is equals to 1 by AB is equals to 9, I will have A is equals to 9. When B is equals to 9, I will have, by AB is equals to 9, I will have A is equals to 1. Okay, by this concept I can have, okay, I can have two answers. Okay, I can have two answers. Okay, now I want to check all the, now for GM checking, A into B, under root A into B will be what? 1 into 9, it will be nothing but 3. So first one is correct. If no matter what value you take, A into B will be 9 only. So my first option is correct. Now the possible value of A plus 2B, A plus 2B will be 11. Okay, possible means by any value which you consider it should be 11. So if I take it as 9 and if I take it B as 1, then it will be 11. So my second option is also correct. Now let's check for A plus B arithmetic mean. AM of arithmetic mean is 6. Okay, so A plus B by 2 is what? This is 10 by 2, which is nothing but 5. So this one is wrong. Now greatest value of A minus B is 8. So can greatest value of A minus B be 8? If I take A as 9 and B as 1, it will be equal to 8. So my fourth option is also correct. So last part is means by getting the value you have to check the options. Okay, that is the easiest part. Okay, nothing big issue in that. Okay, now here three options are correct and one option is wrong. Now let's move on. Okay, in the next option, which is 28th. Okay, 28th is if A comma B and C are in HP, then the value of AC plus AB minus BC into AB plus BC minus AC upon A into B into C the whole square is. Okay, now I will break ABC. Okay, this pattern is very general. Okay, in limits you will come across this. Okay, you have to do whenever some square appears and something like this appears where AB is easy, you have to break AB into two parts and then give it to this part and this bracket. Okay, like this. So if I do that, AC plus AB minus BC upon what? ABC into AB plus BC minus AC upon ABC. If I do this, it will break up into B, it will break up into C, it will break up into A, it will, okay, I got this thing, it will break up into C, this will break up into A, this will break up into B. Okay, so I got this thing. Now they're telling A, B, C are in HP, then the value of, okay, so are in HP, so 1 by A, 1 by B, 1 by C are in AP basic, then 2 by B will be what? 1 by A plus 1 by C. Okay, by using that I can write also one more thing. Okay, after here A, 1 by A will be what? 2 by B minus 1 by C. Okay, now let's substitute the value 1 by B plus 1 by C minus 2 by B plus 1 by C. Okay, I have substituted my 1 by A value, and here 1 by C plus 1 by is nothing but 2 by B minus 1 by B. Okay, so here what will happen? Minus 1 upon B will this, and this will be what? 2 by C, and this will be nothing but 1 by B. Okay, so I will do what? I will cross multiply. Okay, right, we will cross multiply, or I should not multiply. Okay, I can see the options. I don't need to multiply. 2 upon BC minus 1 upon B square. Okay, so I got this thing. Okay, I got this thing. Okay, now I have to check for the next option, but here these two options I have checked. This one is correct, so this one automatically be wrong. Okay, after this we have to check, but here how we can check? Here there is no B term, so I have to eliminate the B term from here to get this. Okay, but from HP I know that B will be nothing but AC upon A plus C. How it came? You can just modify this equation and get B value. Okay, now I will substitute here 2 upon 2AC A plus C. Okay, this will be what? A plus C. Okay, fine. Okay, this will be C 2ac into C. This will be 1 upon, this will become 4a square c square into a plus c the whole square, a plus c the whole square. Now 2 will cancel out, giving me here a c minus, I will take a plus c is, here it is 4a square c square, I will take a plus c common. Why? Because I know there is a plus c. Okay, or a minus c, here I cannot form a minus c, a plus c is there, so I will take a plus c, so my half part is prepared. Okay, so in calculation there is also trick. Okay, so you have to be curious. Okay, means cautious. And now I have to create here, it is c square, but I have to create here a square, and I have to multiply and divide by 4 also. So I will multiply by 4a, giving me 4a square into c square. Now my base is same, minus a minus c upon a plus c, which will give me 3a minus c into a plus c upon 4a square into c. Okay, so this one is the correct. Okay, why I didn't after this step also we can click, because a plus c, okay, is this gives a direct hint that this part will not be there. Okay, so which gives us hint that this will be the answer. Okay, so here 1 2 3, okay, 3 options are correct. Okay, hope you have understand the process clearly, how we proceeded. Okay, our mentality about the process. Okay, now let's move on to the next question. The next question says 29th, if p comma q and r are in ap, then which of the following is slash are true? Pth, qth and rth terms of an ap are in ap, qth, pth, rth terms of gp are in gp, pth, qth and rth term of an hp are in hp. None of this. Okay, if p q r are in ap, then which of the following? Now listen, I have told you about ap, it is true for gp also. If I take the pth term, okay, or if its value is p, okay, then and if I take qth term and its value is q, if I take the rth term, its value is r, okay, then you know that r minus q upon q minus p and r minus q upon term, okay, rth and qth term upon upon qth minus pth term, if it is rational number again rational, then it will be true. Since they are in ap, so it will be rational number. Okay, they are in ap. We do this what to prove they are in ap. If they are in ap, then it is equal to this also, so terms are also in ap. If it is true for ap, then it will be true for hp. So my first option for ap and this is true. Fine, now we want to check for gp. This is pth term, okay, a into r power p minus 1. Fine, pth term, okay, some pth term, okay, p minus 1. Okay, let me pth term as some, okay, pth term, okay, they are telling the value p and q and r. Okay, the pth term, let's say its value is x, okay, in gp, and y value is what, a plus r upon q minus 1, and z value is what, a into r upon capital R minus 1. Okay, now if I do y upon x, it will be what, r power q minus 1 upon r power p minus 1, and z upon y, if I do, it will be what, r upon r minus 1 upon r upon q minus 1. Now if you observe, this is what, this what I have taken, x y z y I have taken, because it is nothing, they have given us the value. Okay, okay, so they are telling the pth qth term of an pth qth term of gp. So these terms, okay, these terms, okay, are in gp. If they are in gp, then this will also be true, they will also be in gp, so which indirectly gives us that. But in the previous problem which we were doing, we have to prove that they can be a terms of an infinite gp. Okay, that was different thing and this is different thing. Okay, but this ap and hp concept is applicable to all types of question. Okay, you can use it without any fear. Okay, so here hope you have understand how we did. In ap we use this rational number concept. For hp it is also true. For gp we know that the terms are in ap, so the terms ratio are in gp as per the rule. Since they are in gp, so there means the value should also be in gp. So we came to no conclusion. Okay, the terms are in gp, so these terms will be gp, it will move up, okay, and it will create a gp only. So these are in gp. If the terms means this ratio is in gp, then it will also be in gp, vice versa. Okay, so second option is also correct, although there is no reason to solve this question because it is a direct type question and it will never appear in exam. Okay, Okay, now let's move on to the 30th question. The 30th question is this question, which says if x square plus 9y square plus 25z square is equals to x into y into z is equals to into 15 upon x plus 5 upon y plus 3 upon z into, then first x comma y and z are in HP, 1 upon x comma 1 upon y comma 1 upon z are in AP, x comma y comma z are in GP, 1 upon x comma 1 upon y comma 1 upon z are in GP. Okay, I can open this first thing, 25z square, this will become what, 15 yz, this will become what, 5 xz, this will become 3 yx. Okay, after this step I can write it as 3y the whole square. I will tell you why I am writing it. Okay, if you cannot realize, means your class 5 concept, okay, class concept were weak. Okay, you have not done your class 10th, okay, properly, or 9th. Okay, x into 5z in plus x into 3y. Okay, now I will tell you how it came from this, a square plus b square plus c square. Okay, a square plus b square plus c square is equals minus, okay, a square, okay, it will be, okay, I should take ab, x square plus y square plus z square minus xy minus yz minus zx, okay, is equals to what, x minus y the whole square plus y minus z the whole square plus z minus x the whole square 1 by 2. Okay, this is the formula. When I saw this, I can make it 3 square 25. This is very best. Okay, this formula IT uses it many times. Okay, IT's favorite part is this formula. Okay, they use it many times. Okay, so the basic thing is here that x square 3 square. So I analyze this formula. I will bring this thing here, x square plus 3y the whole square plus 5z the whole square minus 3y into 5z minus x into 5z minus x into 3y will should be equal to 0, but this is, okay, this is equals to what, 1 by 2 x minus 3y the whole square, okay, plus 3y minus 5z the whole square plus what 5z minus x the whole square, which will give me nothing but equal to 0. So when the square of three terms can be 0 only if all the terms individually become 0. So x minus 3y should be equal to 0. Okay, so the terms will become individually 0, then only it is possible. So 3y minus 5z should also be equal to 0, 5z minus x should also be equal to 0. So x is equals to 3y, 3y is equals to 5z, and 5z is equals to x. Okay, now after this step, okay, we can do one thing, x is equals to 3 by y, x is equals to 5z. Okay, and similarly, okay, x, if I consider x is equals to 1, then y will be what, 1 by 3 x terms, and z will be what, 1 by 5 in x term. So 1 comma 1 by 3 comma 1 by 5 are the terms, okay, in x. Okay, now we want to prove the things. Okay, the proving that things means like they are telling that x comma y comma z are in HP. Okay, for that, okay, now the terms are 1 by 3 1 by 5. Okay, we want to, okay, so my x is 1, my y is 1 by 3, my z is 1 by 5. Okay, now if 1 by x, 1 by y, 1 by z are in AP, okay, it means that 2 by y should be equal to 1 plus 1 by 5. Okay, 2 by y, okay, 2 by means 1 by 3, okay, which is 2 by y. Okay, 1 by x, this will become 2 into 3, which will equal to 5. 2 into 3 will become 5 plus 1 by 2. Okay, let me check, wait a minute, this, wait, 1 upon x, 1 upon x is 1 only, 1 upon z, 1 upon z it will be 5, 1 upon z will be 5, which will, this will be 6, and this will 5 plus 1 6. Okay, and if 1 upon x, 1 upon y, 1 upon z are in AP, I have just proved are in AP, then the first one is automatically proved that x, y, z are in HP. Okay, going for AP is quite easy compared to HP, so I went for this and I got this in bonus. Okay, now I want to check for GP. Okay, whether it is true for GP, so let's check. Okay, now x into y square is equals to x into z. Y square is 1 by 9 is equals to 1 by 5, not a choice. Okay, and similarly goes for this one. Okay, so they are not, and first and second are the only answers. Okay, now let's move on. Okay, hope you have understand how we proceeded. We identify this formula, then we equated the terms individually equal to 0. 1 by 2 has no rule, it will go and become 0. And then we considered x is equal to 1, then we got 1 by 3, 1 by 5. Okay, no matter what you consider, it will cancel out in the end. If I consider it as m by 3, m by 5, will removed. X is equal to 1, y is equal to 1 by 3, z is equal to 1 by 5, then 1 upon x, 1 upon x. We have proved it. It will be 2 upon y. 1 plus 1 upon 5 will become 5. This 2 into 3 will become 6. 5 plus 1 is 6. Okay, so we have proved this thing. Now let's move on to the next question, which is our 31st question. Okay, and this question, okay, this question is quite time consuming, but if a1 comma a2 comma g1 comma g2 and h1 comma h2 are two arithmetic, geometric and harmonic means respectively between two quantities a and b, then ab is equals to what? Now we have to find a1, h2, a2, g1, g2 and check out all these conditions which they have given. Okay, so we know between a1 and a2 are there, okay, and b, so I can get d. Okay, what? B minus a, first term upon n plus 1. N is what? Number of terms between them. It is b minus a upon 2 plus 1, which is give me b minus a upon 3. So can I get my a1? Yes, I can easily get it. A plus b minus a upon 3, which will give me 2a plus b by 3. Okay, so a2, how I can get a2? A2 will be nothing but 2 into b minus a by 3. Okay, so b is equals to a plus this, and which will give me what? This will give me 2b plus a by 3. Okay, so I got my a2 also. Now similarly I can do a between a1 and a2, g1 and g2 are the gp's, then it will form geometric means I know the formula to get r here, b by a upon 1 upon n plus 1, which will give me b by a upon 1 upon n means 2 plus 1, which will give me b by a, number of terms 3. Okay, so can I get my g1? In gp how we get? A into r, okay, for first term, and then for second a into, okay, a r square, like that. So a into b by a upon 1 by 3, which will give me a power 2 by 3 into b power 1 by 3. G2 will be what? A into b by a power 2 by 3, which will give me a power 1 by okay, a power 2 by 3. 2 by 3 minus will give me 1 by 3. A power 1 by 3 into b power 2 by 3. Okay, so now let's move on for the d for h1 and h2 between a, b, a1, h1, h2 and b. 1 upon a, 1 upon h1, 1 upon h2, 1 upon b are in a gp. So 1 upon h1 I have to calculate d first. Okay, 1 upon b minus 1 upon a into n plus 1, which will give me nothing but a minus b upon ab into 3. Okay, so I got my d. So can I get 1 upon h1? It will be 1 upon h1. Okay, 1 upon a is equals to 1 upon a plus, don't write it 1 upon d, it will be d only. Okay, many children do this mistake. Okay, which will give me 1 upon a plus a minus b upon 3ab, giving me finally a plus 2b upon 2a. It will be what? 3ab. Okay, so what I am getting? h1 is what? 3ab upon a plus 2b. Don't forget to convert it, means take the reciprocal. Similarly we will find h2. H2 will be 1 upon a plus twice d, which will give me 1 upon a plus twice a minus b upon 3ab, which will give me 2a plus b upon 3ab, which will give me finally h2 is nothing but 3ab upon 2a plus b. Okay, now we will check the condition for a1 and h2, which will be what? It will be nothing but 2a plus b. I have told you in the starting only, this question is very easy, but it is time consuming. Okay, 2a plus b, I am checking by multiplying, it is ab, and a2, okay, it is ab is equals to, okay, fine, first option is correct. A2 into h1 is nothing but a plus 2b upon 3 into what? 3ab upon a plus 2b, which will give me what? ab again. Now the last g1 into g2 will be what? a2 a 2 by 3 into b 1 by 3. Okay, here a 1 by 3 into b 2 by 3, which will give me, this will become 2 plus 1 3. Okay, this will what? 3 by 3, and this will be what, 3 by 3, which will give me AB. So all the three are true. Okay, all the three are true. Okay, A1, all the values are equal to AB only. Okay, now let's move on. Okay, this question is nothing but just you should know the arithmetic, geometrical, harmonic mean. Okay, I don't have nothing to explain. Consider the terms, get the D, get A1, A2, but be very cautious while getting the harmonic mean. First you have to take it 1 by H1, then you have to take 1 by A, don't take it 1 by D, and then reciprocal the H1 and get the H1. Similarly, get the H2 and get your answer by multiplying, by putting the values A1 into H1 and so on. Now let's check for the next question. Okay, the next question is as follow. Okay, the next question is this 32 question, which says if 1 upon b minus a plus 1 upon b minus c is equals to 1 upon a plus 1 upon c, then first a comma b and c are in HP, second a comma b and c are in AP, third p is equals to a plus c, fourth 3a is equals to b plus c. Now one thing is very obvious, 1 upon b minus a plus 1 upon b minus c is equals to 1 upon a plus 1 upon c. Now I have to make a plus b, three terms should be there. So instead of taking c here, a here, because a minus b will make a not three terms. Okay, all should have different terms because I have to put a, b, c are in HP, a, b, c are in AP here also. So I will take b minus a minus c. I'm telling how you have to take the terms also from that side to that side. Okay, that idea you should also know. So I will multiply c into minus b plus a, okay, upon c into b minus a. Here it will become what, b minus c minus a upon this into b minus c. They are equal. If I take minus sign from here, it will be c minus b plus a upon what, a into b minus c. They will cancel out. Okay, instead of cancelling out, it will create a problem only. C minus b plus a upon c into b minus a. I will move it that side. I'm not cancelling out. Okay, I move it that side. It will become c minus b plus a upon a into b minus c. Fine, should be equal to 0. I will take common c minus b plus a. I will be left with 1 upon c into b minus a plus 1 upon a into b minus c should be equal to 0, which will give me, there can be two situations, c minus b plus a should be equal to 0, which will give me b is equals to a plus c. So my third one is correct. Okay, because it can be equal to when it is equal to or it is equal to 0. So if it is equal to 0, then it should be true. Then here we will multiply, which will give us what, ab plus ac, ab minus ac, sorry, ab minus ac plus cb minus ac upon this ac into b minus a into b minus c. Okay, so this will become ab minus 2ac plus bc upon ac into b minus a into b minus c. Okay, should be equal to 0. Okay, now here this will move that side and become 0, which will give me finally ab plus bc should be equal to 2ac, which will give me a plus c, take b common, 2ac. Okay, which will give b is equals to 2ac upon a plus c, which is indirectly a HP in what, 1 by a, 1 by b, in a comma b comma c. Okay, are in AP, and it will be 1 by a, 1 by b, 1 by c if it is in AP. Okay, so first one is true. Okay, and the rest are false. First we take what term to take that side, ABC. I want to create all three terms, ABC terms. Okay, so I will take C or not take 1 by a that side. Then I multiplied, I take that common. Okay, there can be two way, either this becomes 0 or this become, when I make it 0, I get this thing. When I try to solve it and make it equal to 0, suddenly I get a condition like this. Okay, I multiplied and I make it equal to 0, then last thing I have to make it equal to 0. When I make it equal to 0, I get a HP condition, which indirectly proved that ABC are in HP. Okay, so first and third are the answer. Now let's check for the 33rd. If a comma b comma c are three distinct numbers in GP, b comma c comma a are in AP, and a comma bc and comma abc are in HP, then the possible value of b is what? Okay, now here since the numbers are in, okay, I will take a is equals to a by r, b is equals to a. Okay, I will take, okay, b is equals to a and c is equals to a by r. In three terms are in GP, I consider them a by r, a and ar. That is the thing which are taught to children. Okay, now are in AP. Okay, now the second condition, 2C is equals to B plus A, because they are in AP. Okay, now if I substitute the value here, okay, what I have, 2 into A into R, okay, is equals to A by R, okay, plus A. Okay, so this will be what, A will cancel out, giving me 2R, 2R, 2R into 1 by R plus 1, which will give me 2R square plus 1 plus R, it should equal to 1 plus R. Okay, which will give me finally 2R square minus R minus 1 should be equal to 0. Okay, which will give me, if I get the R value, which will be what, 1 plus minus under root 1 plus 8 by 2 into 2, which will give me 1 plus minus 3 upon 4, which will give me R is equals to minus 1 by 2, or R is equals to 1. Okay, so we are getting our two values, R is equals to minus 1 by 2 or R is equals to 1. If R is equals to 1, then all A comma B comma C will be equal, but they are telling they are distinct, so R cannot be equal to 1, so R is equals to minus 1 by 2. Okay, so we got this thing. Now from here I can get that A is equals to minus 2A, okay, B will be what, A, C will be what, minus A. So I will simplify this further, okay, which will give me 1 by, okay, in the, okay, so I have got my A, B, C value. Now for the HP, what, A 1 by BC, 1 by ABC will be in AP. Okay, so after this 2 by BC will be equal to 1 by A plus 1 upon ABC, okay, which will give me finally 2 upon BC should be equal to what, 1 upon A I will take common, which will give me BC plus 1 upon BC, okay, which will give me finally 2A is equals to BC plus 1. Okay, now I will substitute the value, which will be minus 2 into 2A, which will be A into minus A by 2 plus 1, giving me finally minus 4A is equals to minus A square by 2 plus 1, giving me minus 8A. I will multiply throughout by A 2, which will give me this, and finally I will be left with minus A square. Okay, A square minus 8A minus 2 is equals to 0. If I try to get A value, 8 plus minus under root 64 plus 8 upon 2 into 1, which will give me 4 plus minus 3 root 2. Okay, so the only A values which are here possible is 4 and 4 minus 3 root 2. Okay, here what we did, we was calculated these things. Okay, now the other approach can be, you can take B is equals to A plus D, this, and C plus D, and then you have to get the GP condition and then solve it. That is one method. The next method, okay, so we will have different values. Okay, at A is equals to minus 2A, B is equals to A, and C is equals to minus A. And then listen, the other approach can be GP, you can consider at A, AR square and AR, okay, like that. Okay, and A, here you can solve it by AP, starting from A plus D, A plus 2D, like that consider, and use the GP condition and solve it. Okay, all the method will give you same answer, just I'm telling you the approaches. You can take different approaches, it depends upon your mind. Okay, now let's move on to the next question, which is 34th question. Okay, which is also an important question. Okay, it will teach you many things. Okay, and okay, the question is like this: if A comma B comma C are in AP and A square comma B square comma C square are in HP, then which of the following E slash are possible? First, AX square plus BX plus C is equals to 0 has imaginary roots. Second, AX square plus BX plus C is equals to has real roots. A comma B comma minus C by 2 form a GP. A comma minus B comma C by 2 form a GP. Okay, so now let's check. Okay, so the first thing is very obvious, that ABC are in AP, so 2B is equals to A plus C. Okay, which will give you, okay, since ABC are in AP, so I can also write them that B minus A should be equal to C minus B. Okay, I can write them easily in this manner. Okay, it can be useful. Now 1 upon A square, 1 upon B square, 1 upon C square are in AP. R in AP, fine, it is very simple, R in AP. Then 2 upon B square should be equal to 1 upon A square plus 1 upon B square. Then I will do the similar thing which I did, 1 upon B square minus 1 upon A square, okay, is equals to 1 upon C square minus 1 upon B square, okay, which will give me A square minus B square upon A square B square, which will give me 1 upon, okay, this will be what, B square minus C square upon B square C square. Okay, here I will apply A minus B into A plus B, okay, upon what, AB, A square B square, and here I will apply B minus C into B plus C upon C square B square. Now listen, here I have c minus b and a minus b is equal. If I take minus sign outside a minus b, it will become this, and if I take minus outside b minus c, it will become this. So here the minus sign will cancel out and this will also cancel out. Okay, so what I will be left with will be like this. Okay, what I will be left with a plus b upon a square. B square also will cancel out the bottom one. Okay, I will cancel the b square also. Okay, so what we are left with, a plus b by a square should be equal to b plus c upon c square, which if I multiplied, I get ac square plus bc square is equals to a square b plus ca square. Okay, here I get ac into c minus a plus b into c square minus a square is equals to 0. Okay, now here ac into c minus a. Okay, here b into c minus a into c plus a square minus b square I will apply. C plus a should be equal to 0, so I will take c minus a as common. Okay, c minus a common, ac plus b into c plus a should be equal to 0. Okay, but for it to be equal to 0, this should become either this or this should become 0. If I equate it to 0, I get c is equals to a. Either this or this should become 0 for it to be equal to. So if I equate it to 0, I get c is equals to a. Now I will equate the second part, that is ac plus bc plus ba should be equal to 0. Now see what it gives us. It will give us nothing but, okay, this I will take b common. Okay, b common from c plus a, which will give me plus ac should be equal to 0. Okay, so 2b. Okay, sorry, I am doing something wrong. Okay, I know 2b is, okay, sorry, a plus c I can write 2b, because from the first step 2b is equals to a plus c into b plus ac should be equal to 0, which will give me 2b square is equals to minus ac. Then I will move the 2 that side, will give me a into minus c by 2. Okay, so I got, so it is very clear that they are in gp. They are in gp. Okay, in gp what are in gp? A, b minus c by 2. Okay, are in gp. Okay, now we have to check for this equation. Okay, either it has imaginary roots or real roots. Okay, for ax square plus bx plus c is equals to 0, alpha by beta is sum of root is c by a, and I know a and c are equal, then it is equal to 1. While alpha plus beta is what? Alpha plus beta is minus b by a. I can write it minus 1 by 2 c plus a. Okay, a plus c by a, which will give me nothing but this. I can write as, okay, 2 into 2a, because c and a are equal, so it will become 2a. This will become equal to 1. Okay, so here, okay, here since you can see that a plus c, okay, a and c both are equal. Okay, we have derived this condition by equating it equal to 0. I can write it as 2a. Okay, which will give me 2 by 2 will become, okay, this, okay, this will not be 2. Okay, this is 2. Okay, so this will cancel out, giving me 1. Okay, so finally what we are left with, okay, we are left with sorry for the noise, the peoples are shouting a lot, okay, around here. Okay, so 2a will cancel out, giving me finally, okay, this will become 2, and here I have 2 also. The a will cancel out, giving me minus 1. Okay, so sum of root I have what? Minus 1. Okay, now if I apply a square into sum of the roots times x plus product of the root should be my equation. So x square minus into minus 1 into x plus 1 should be equal to 0. X square plus x plus 1 should be equal to 0. If I check its d, it is what? 1 minus 4 into 1 into 1, which is negative, less than 0. So roots are imaginary. Okay, very obvious. Okay, so now we have proved that they are imaginary. We have proved, okay, that they are in gp. Okay, form a gp. Okay, so these two options get automatically rejected as they have real roots and that thing. Okay, now let's move on to the last question. Okay, to the okay, sorry, not the last question. Okay, 35th question, which is the corresponding first and, okay, so the corresponding first and the 2n minus 1 term of an AP, a GP and HP are equal. If the nth term are a comma b and c respectively, then, okay, which one is true? A is equals to b is equals to c, a greater than equal to b greater than equal to c, a plus b is equals to c, ac minus b square is equals to 0. Okay, now let the first term be x. Okay, and the 2n minus 1 term be y. Then what we are left? X a y are in am, x, b, y are in gm. Okay, b. Now this is first term, this is n term, this is 2n minus 1 term, so this will be last and this will be in between, and this, and they are in gp. Similarly, x, c and y are in what? Are in hm. Okay, so from this, since they are in am, a is equals to what? X plus y by 2, b is equals to what? Under root xy gm condition, and c is equals to 2xy upon x plus y. Now this is am, this is bm, and this is gm. This is gm and this is hm. Okay, so here a is am, b is gm, c is hm. So we know that am is greater than or equals to gm, is greater than is equals to hm. So by this, a is greater than equal to b is greater than equal to c. Similarly, we can prove one thing also, that is, you know that g square is equals to ah. I have proved this in our lectures. Okay, using this, b square is equals to a into c, so ac minus b square is equals to 0. Okay, so fourth and second are the answer. Okay, now we will move on to the last question. Okay, which is as follow. Okay, which is as follow. Let me get the question. Okay, the last question is this one. Okay, which is this: let e is equals to 1 upon 1 square plus 2 upon 2 square plus 3 upon 3 square, and so on. Then e is less than 3, e is greater than 3 by 2, e is greater than 2. So now for this question particularly, you should know a relation that this series e lies between two series. Which series? It lies between one series which is 1 upon 1 plus 1 upon 2 into 3, and 1 upon 3 into 4, and so on. And while it lies from 1 plus 1 upon 1 into 2 plus 1 upon 2 into 3, and so on. Okay, so this is additional information which you should know, that this series is lies between this, to solve this greater than equal to type question. Otherwise we can have directly calculated sum, but it is asking for relation which you can solve if you know the relation between that this lies in this between these two series. Okay, 1 into 2, 2 into 3 into 4. Now if I simplify 1 into, okay, this one, 1 plus 1 minus 1 by 2 plus 1 by 2 minus 1 by 3, and so on. Now if I open this, this will cancel out with this one, and so on. All the terms will cancel out. Okay, so we will be left with 2 only. While here if I open this, I will get 1 by 2, 1 by 3. I can write it like this: 1 by 3 minus 1 by 4, and so on. Now if you see here 1 and 1 by 2, then this will cancel out with the next 1 by 3, and this will cancel out with the next 1 by 4. Okay, this will cancel out, so left will be 1 and 1 by 2, which will be nothing but 3 by 2. Okay, so e will lie between 3 by 2 to 2. Okay, so e is greater than 3 by 2, right? And e is less than 2. Okay, so second and fourth are the answer, and after this question we are done with multiple correct option. Okay, we will do comprehension type questions in the next lecture, but till then you should practice. Okay, I will teach you again what I've done. This series lies between these two series. Okay, that you should all know before only. If you don't know, then you cannot solve this question. So I just write this question series, that is 1 upon 1 by 2 into 3, 1 upon 3 into 4. It gets okay. So this series lies between these two. Okay, and you should know this, and till then take care. We are done with this, and after this you can break it into 1 by 2 and 1 by 3. That is means this is just observation skill, and they already told you to remember its value, it is 2 and 1 by 3. That's also many teachers tell you, but I have proved that how it breaks up. Okay, and that's all. Take care. Bye.